Hello everyone, welcome to today's session. In this session, we're going to cover formal charge. Before we can look at this topic, let's try to understand what formal charge is all about. So when you're talking about formal charge, it is just an electric charge which an atom would have if not bonding electrons were shared equally between its neighboring atoms. So that is what basically formal charge is all about. So we are saying it is just an electric charge which an atom would have. So an electric charge which an atom would have if let me go to next slide. Okay. Right, so you're saying it's an electric charge which an atom would have if not bonding electrons were shared equally between its neighboring atoms. Okay, so basically that is what formal charge is all about. So this formal charge, it helps us to determine or identify the correct Lewis structure. Okay, so that is the importance of formal charge. Helps us to determine or identify correct Lewis structure. So you can be given a lot of Lewis structures and you can be asked to determine or identify which among those is the correct one. Okay, so when you are calculating formal charge, there is a formula you need to use. So I will say FC to symbolize or denote formal charge is equal to the valence electrons minus, I'll say Be to symbolize the bonding electrons, then plus the non-bonding electrons. Okay, I'll say NBE. Okay, so formal charge is equal to the valence electrons minus, open bracket, the bonding electrons plus the non-bonding electrons. Okay, these non-bonding electrons can also be referred to as the unshared electrons. Let me use unshared electrons. Okay, or we can say non-bonding electrons. Okay, so I'm saying non-bonding electrons can also be referred to as unshared what electrons. Okay, so we can write this formula as, can also write it as formal charge is equal to the valence electrons minus open bracket the bonding electrons plus the unshared electrons, like this. Okay, so basically this is the formula you can use. It is just formal charge is equal to valence electrons minus bonding electrons plus unshared electrons, and these must be in parentheses. Unshared electrons, also known as non-bonding electrons. Now let's look at an example to cement this concept you just learned. So let's say I have this compound. Let's have this compound. You know that we obey the octet rule, so we need to complete the number of lone pairs on oxygen to fill the octet rule, or to satisfy the octet rule. Okay, so we have this. As our compound. Then we are asked to calculate the formal charge. Let's say calculate the formal charge for each and every compound in this structure. So let me go to the next slide. So basically what I'm going to do here is first to write the formula. So I'm going to say formal charge is equal to the valence electrons minus the bonding electrons plus the unshared electrons or non-bonding electrons. So I'm going to say formal charge, let's say for sulfur, let me begin with sulfur, will be equal to, what's the valence for sulfur? So we'll discover that sulfur is in the same group as oxygen. The valence for sulfur is 6. Then we're going to say minus, so we go to the bonding electrons. How many electrons are involved in bonding when you look at sulfur? So we can look at this element sulfur. We discover that the bonding electrons are, if we count here, this sulfur, there is a bonding electron here. Okay, sulfur has donated 1 electron there to form a pair, to form this bond. Even there is an electron for sulfur. Even there is an electron for sulfur. Even there is an electron for sulfur. So the bonding electrons are simply 1, 2, 3, and 4 here. Okay, they are simply 4 electrons. So the bonding electrons are 4. So I'm going to say open bracket 4 plus. Now we look at the non-bonding electrons or unshared electrons. You can see that on sulfur there is no non-bonding electron. All the electrons are bonded, there is no non-bonding electrons. So the non-bonding electrons, it is just 0. Okay, so formal charge for sulfur will be equal to 6 minus 4 plus 0, that is just 4. Then we're going to have 6 plus 4 giving us plus 2. So this is basically the formal charge for sulfur. Let's look at the formal charge for hydrogen. Let's look at formal charge for hydrogen. So in this structure, you can see that hydrogen is here and is also here. The formal charge for hydrogen at this point is the same as the formal charge for hydrogen at that point. So let's calculate the formal charge for hydrogen. We can see that the valence for hydrogen. The valence for hydrogen is just 1 because there's only one electron in the outermost shell of hydrogen. Excuse me. So we're going to say minus, open brackets, the bonding electrons. The bonding electron here, hydrogen has just donated 1 electron, so that is a bonding electron. So I'm going to say 1 plus the non-bonding electron. You can see that hydrogen has no non-bonding electron. There is 0 non-bonding electron, so I'm going to say plus 0. So the formal charge for hydrogen will be equal to 1 minus 1 plus 0, that is just 1. So it will be 1 minus 1, giving us 0. So hydrogen basically has a 0 formal charge in this compound. Now let's look at the formal charge for another element. Let's look at for oxygen. Okay, so let's start with this oxygen here. So there should be another pair of electron there. Satisfy octet. So let's look at the formal charge for this oxygen. The formal charge for this oxygen is the same as the formal charge for that oxygen. Okay, so let's calculate it, but it is different from the formal charge of that oxygen there. So let's calculate first the formal charge for this one, which will be equal to the formal charge for that one. Let's do so. So I'm going to say a formal charge for oxygen will be equal to the valence electrons. The valence electron in oxygen is in group 6, so the valence is 6 minus the valence electron is just 6. The valence number is 2. Okay, that's the difference. Okay, now let's look at the bonding electrons in oxygen. The bonding electron, you can see that oxygen has donated 1 electron there. It has also donated 1 electron there to form these pairs. So the bonding electrons, we can say 1, 2. They are just 2. So we're going to say open brackets 2 plus the non-bonding electrons. In oxygen, the non-bonding electrons, you can see that there's 1 there, 2, 3, and 4 there. So there are 4. Okay. So the formal charge for oxygen, the formal charge for oxygen will be equal to 6 minus 2 plus 4, that is 6 again. So it will be equal to 6 minus 6, which is 0. So that is basically the formal charge for oxygen in that compound, for this oxygen and for that oxygen. Okay, now let's look at the formal charge for this oxygen, which is equal to the formal charge for that oxygen. So how are we going to calculate that? So basically we are going to say formal charge is equal to the valence electron. We know that the valence electron for oxygen is 6, then minus, open bracket, the bonding electrons. The bonding electrons we can count. There's just 1 bonding electron there. Okay, oxygen has just donated 1 bonding electron. So we're going to say 1 plus. Then we look at the non-bonding electrons. Okay, so the non-bonding electrons, now we count them. There's 1 there, 2, 3 there, 4, 5 there, 6. So we are getting that the non-bonding electrons in this compound, there are 6 non-bonding electrons. Okay, if we count, because to satisfy the octet law, we have 2 electrons there plus 6 electrons which are not involved in bond, or in bonding rather. So this is what is giving us the value of 6. Okay, so 1 there, 1 electron which has been involved in bonding, plus 1, 2, 3, 4, 5, 6 electrons which are not involved in bonding. Okay, so what is it about this oxygen? So how can we calculate now the formal charge for this particular oxygen? Okay, how can we calculate the formal charge? So I'm going to say formal charge is equal to 6, that is the valence, minus 1, that is the bonding electrons. Okay, the bonding electron, just the bond which is involved, or the electron rather, which is involved in bonding, then plus the electrons which are not involved or which are not participating in bonding. Okay, so we're going to discover that we have 6 electrons. Okay, we have 6 electrons which are not involved in bonding. So let's calculate the formal charge. So the formal charge will be equal to 6 minus 6 plus 1, that is 7. So we're getting formal charge is equal to 6 minus 7, that is giving us -1. Okay, so you can see that it's giving us -1 as the formal charge at that point. Okay, so what you need basically to understand is that when you are dealing with this particular question, you need to make sure that you write the balanced equation. Now let's look at another compound. So you need to write the correct Lewis structure rather. Okay, you need to write the correct Lewis structure in order for you to be able to determine the formal charge. So you can see that the ammonia, it is NH3, it has 2 lone pairs there, or nitrogen. Now let's determine the formal charge of nitrogen in that ammonia. Okay, so I'll go to the next slide. Okay, so let's calculate the formal charge. So formal charge will be equal to, we are calculating for ammonia, which is like this, and there with 2 lone pairs, then hydrogen, and another hydrogen. So there are 2 lone pairs there. So how can you calculate the formal charge? So formal charge will be equal to, we're calculating for nitrogen. The valence electrons in nitrogen, there are 5, then minus the bonding electrons. The bonding electron, there's 1 bonding electron there, plus 1 there, so there are 3. Then plus non-bonding electrons, you can see that there are 2 lone pair. There's 1 lone pair consisting of 2 electrons which are not involved in bonding. So the formal charge for nitrogen will be equal to 5 minus 3 plus 2, that is simply 5. So formal charge will be equal to 5 minus 5, which is just a 0. Okay, so basically this is how you can calculate formal charges. Thank you for watching.